Hello and welcome back. This is Greg French. Today we're going to be going over Chapter 1, Part 3 in this computer repair series. Again, hardware. Motherboard components used for communication among devices. We have traces and circuits or paths that move data and power. If you examine a circuit board or a motherboard, you'll see that there are lots of what we call traces. These are copper conductive paths that are on the board, and this is what allows both data and voltage to move around the board. They're called traces. Data bus is a bus that carries data, and generally when you see these traces, there's a bunch of them running parallel with each other. Main bus, system bus or memory bus. This communicates with the CPU memory and chipsets. System clock. These are pulses that are carried on a line on the motherboard. Everything has to be synchronized together, and the synchronization comes through these system clock pulses. Data bus has traces or lines that carry voltage. These voltages are interpreted by the CPU and other devices as bits. As a bit moves along this, it'll either be high or low, and that's a different voltage level. If it's high or 1, generally that voltage is probably around 5 volts. But this is how the bits are interpreted. Clock speed is measured generally in hertz. Hertz is cycles per second. 1 megahertz would be 1 million cycles per second, and we have a designation or a symbol, MHz. Now gigahertz, fairly recent symbol, is 1 billion cycles per second. A lot of our newer CPUs run in the gigahertz, or 1 billion cycles per second. That's a pretty unbelievable speed for devices today, but we've had gigahertz for quite a while. Common ratings for motherboard buses. Buses run at different speeds depending on the performance of the computer. We're always trying to get a higher speed so that we can move data faster. And here's some examples: 1066 megahertz, 800, 533, or 400. The range of the CPU speeds. 166 megahertz would be a fairly old CPU. The 4 gigahertz is where we're running right now on a lot of our newer CPUs. Buses for expansion slots. The CPI, the PCI, the AGP, and the ISA. PCI stands for Peripheral Component Interface. The AGP, which was a new bus interface for the video card, Advanced Graphic Port, and the old industry standard architecture, the ISA, which you don't see very often anymore. Here's an example of a motherboard that still has some ISA slots on it. The ISA slots are these black slots, where the PCI, or the shorter slots, are the white slots. This is 16-bit, the black ISA slots, versus 32 bits for the PCI. There's even an AGP port on here. That would be for a video card. Interface expansion cards. These are circuit cards, which are also might be called adapter cards or expansion cards. These cards connect the CPU to an external device. Example of these cards might be a network card that plugs into one of these expansion slots and it provides network services to the computer. Might be an audio card. There's a lot of different cards that could be plugged in. Video provides a port for the monitor. Sound cards provides ports for speakers. The ports are the plugins on the back of these cards, and you can always identify the ports by the type of plug-in. Network modem we can always determine the function again by these ports. Port for a monitor would be a 15-pin VGA port oftentimes. A network card is going to be a RJ45 connector. Audio would be again different. It might even have a printer port back there that would be even different, maybe even USB. Here's an example of a modem, and here we have some little RJ11 connectors for a telephone. Electrical systems, the power supply, most important electrical component. Power supplies are very important today. We need large power supplies, 500 watts or higher, to support some of these newer computers. Power supplies converts the AC voltage, which is an external voltage, to DC voltage. DC voltage is what our CPU and our components need. Reduces the voltage from 110 to 120 volts down to 12 volts or less. Typically 12, 5, 3.3, and even less for the CPU. Also runs a fan to cool the inside of the computer case. We usually use the 12 volts for the fans, but 12 volts is a little more efficient for running motors. So we have 12 volt motors in our hard drives and our CD-ROMs. We need to keep the temperatures less than 185 degrees Fahrenheit, otherwise we can have component failure. Motherboard has 1 or 2 connectors for the power supply. Today's newer ones only have 1 connector, but you can see with these pictures, this would be the older style here, and it has 2 connectors, where the newer style over here has just 1 connector. In review, CPU speeds. Well, today the CPUs are running anywhere probably between 3 and 4 gigahertz, which is a billion cycles per second, represented by GHz. And there's also the megahertz, which is a million. Data bus and bus speeds. We're always trying to get faster and faster bus speeds on our motherboard so we can move the data faster, get higher performing computers. System clock, that's the pulse that we use for timing in the computer. And that's generated from what we call the system clock. Expansion cards. There's a new type of expansion card called PCI Express. PCI Express is pretty much double the speed for moving the data. And we've gone from a parallel type of bus to a serial. We also have AGP, PCI, which we've discussed, and the ISA. Our power supply, again, very, very important to have a large power supply so that we have plenty of power for all the different components that we use and plug into our computer. Bad power supply can create a lot of problems for you. So you need to spend a little extra money and get a good power supply. Activities. I want you to sketch the motherboard and identify all the parts on it, the CPU, the chipset, the memory, and the expansion slots. Also like you to put anything else on there that you might think of, other ports, and kind of be able to discuss and explain that. Also, I want you to do labs 1.3 and 1.4. This is part 1 and part 2 of using shareware to examine a computer. And there's lots of good shareware out there. The one I think we're going to use and download is Sandra, and we're going to use that to examine our hardware. But again, there's lots of good open source and free software out there that we'll be looking at. And this concludes this chapter 1 part 3. Next and final for chapter 1, we'll be looking at chapter 1 part 4. Again, the hardware. Thank you very much for your time.